To animate cube rolling on the ground, you would have to animate not just the movement on x-axis, of course, but also rotation. And you would need to, for first turn, rotate it around this edge for 90 degrees, and then on the next 90-degree turn, you would have to rotate it on this edge, also 90 degrees, and so on. There is one solution with parenting cubes to 4 empties and animating each empty separately, but I found an interesting and fun way to do that, using math, of all things. And when we look at the animation here, we see that the cube is perfectly aligned with the ground, doesn't go at all beyond the floor, and doesn't slide on the edge. So, how did I do that? I used a little bit of math, which might look a bit overwhelming, but when you split it into parts, it's really not that difficult. So, first part is just rotation. And yeah, it's rotating. Then we have offset on z-axis in height, so that cube is rolling on the ground without ever going in the air or going under the floor. Yeah, that's supposed to be like that. And then we have offset on x-axis, making the cube roll. So, let's recreate it. Let's create a new blend file. Let's save our file right away, not to forget it later. And so that throughout the lesson we can just press Ctrl S and not get distracted. So, first of all, let's scale our cube down twice, so that it's 1 meter by 1 meter by 1 meter, and apply scale. It makes math a lot easier, because if it was 2 by 2 by 2 meters, sometimes we would have to multiply it, and sometimes we would have to divide by 2. To avoid it, let's just make everything 1 and save us a lot of trouble. Let's add a geometry node setup and transform geometry node. Here we need to animate the rotation on y-axis. For that, let's add scene time and XYZ, combine XYZ node. Plug the frame into y-axis. It's a bit too fast. Let's add to radians node. So what this does is transforms whatever value we had into radians. During the editing, I realized I didn't explain the difference between degrees and radians, so let's do a little detour. You can Google degrees and radians and learn it yourself if you find my explanation not sufficient enough. Basically, if we take a circle with radius of 1, then radians is just length of part of a circle at this angle. So at angle 90 degrees, if we transform it into radians, it's gonna be half of pi, because whole circumference of a circle is 2 pi multiplied by radius, and radius is 1. Then circumference of the whole circle in this case is just 2 pi, and radians for 360 degrees is 2 pi. Radians for 180 degrees is 1 pi, radians for 90 degrees is half a pi. At frame 45, cube is rotated 45 degrees, and at frame 90, cube is rotated 90 degrees. So basically, that's exactly what we need. So for z offset, let's add the set position node. Set position XYZ, combine XYZ node into offset, and let's start the math. Frame goes into subtract, actually into second, and we subtract from 135, we subtract our current frame value. This goes into radians, and this goes into sine. It feels like it's almost right. It just goes beyond the floor. Let's use floor modulo 90 and let's put it here. It's almost right, but as we can see, it's just, what is it, 0.207 something off. Why is that? It's because we need the offset from the center to the corner, which is not like half like from here, but is half multiplied by square root of 2. So we divide that by sqrt brackets 2 and plug it back here. And it works. We got perfect offset from the floor. So that cube doesn't go under the floor and doesn't fly off. It always stuck to the floor, at least at one point. The math behind it might seem like a lot, but it's actually pretty simple if we explain it one by one. Floored modulant. What it does is when we have the input and we have a value just goes up. So like on frame 1, that frame input gives us 1. On frame 90, it gives us a value of 90. So that's pretty simple, and what floored modulo does is separates it into those repeating lines. So at frame 89, we still get 89. At frame 90, we get 0. At frame 90, we get 0. And at frame 180, we get 0 again. At frame 179, we get value of 89. And so on. So on each of those points, every 90 frames, it repeats. After that, we subtract it from 135. Why is that? Basically, if we take the circle, and here from the center, we have the 90-degree angle. Starting at 45, then we have 90-degree angle here. And this subtraction allows us to start our calculation from here, and then when we add those 90, we get in this direction, basically on this trajectory. And then we transform it to radians to work with radians instead of degrees. Then we take sine. Sine is, at this particular case, is just height of this point. So sine of this 135 degrees would be square root of 2 over 2. And of this 45 degrees, it's also square root of 2 over 2. And at highest point, sine is, this is a circle with radius of 1. And at highest point, you guessed it, sine is just 1. And sine of 90 degrees is 1. After that, we just divide it by square root of 2. Now let's add the x-axis offset. You would think that you can just animate it like this, put it in the first position, add keyframe, go for frame 90, go x1, and put keyframe here. Go to 180, go x1, and put keyframe here. And use linear interpolation, and it almost feels right, but something is off. If we look closer at the axis of our rotation, the cube is sliding here. And I tried to fix it with some interpolation curves by using Bezier and all of that. It doesn't work. So let's go back to frame 0 and delete. Make sure to go to frame 0 and make sure the rotation now is at 0, dimensions are 1, scale is 1, and location is 0. So what do? We go into math. Let's adjust it a bit, just so it looks better. And now let's just duplicate it, because it's gonna be basically the same math. Make sure you plug the value into top one. And for x-axis offset, we need to use cosine instead of sine. And let's use another set position node. We could use like plug it back here, but I like it to be a bit more separated, just to have more easier to understand separation between rotation, offset, another offset. Let's add XYZ, combine XYZ node, and offset on x-axis. Let's see how it looks. It looks right, but it repeats every 90 frames. So we need to add just a few more nodes. We need to have right here, we don't need to add anything. Here, we need to add 1. And then for another 89 frames, we don't need to add anything. And then here, we need to add 2, just so it's like here. For that, we just divide it by 90 and floor, just so that output here is always the whole number. And if it's like here, value is like 0.5 something, here the value is going to be 0. But when it goes beyond 90, so that divided by 90, it's over 90, it's between 1 and 2, here the value is going to be 1. And we just add it here. Let's switch them up and put it here. And this is pretty much it. As we can see, cube rolls perfectly without sliding at all. And that's pretty much it. Now we can just multiply our... Nope, not that. Multiply our input, let's say by 10. And all that's left is just set up camera in any way you want, and the scene overall, and render it out. I leave it all up to you, but maybe I will post the lesson to what I did exactly. Tag me if you do something great with it. I would love to see what you come up with, and hopefully I'll see you again soon.